the brain has to somehow generate this internal representation of what you're seeing. Basically, what any organism has to do is take their sensory data, their visual data, their auditory data, the somatosensory data of feeling and touch, and construct an idea of what's really going on. Because, of course, the brain is just enclosed in this bony skull, and the only things going into the brain are time series data carried mostly through nerves, and somehow in this dark bony cavity we are generating some sort of conscious experience. So how does that happen? Well, there is a technically, mathematically optimal way of taking data and trying to figure out what's going on. And that's called Bayesian inference. And the way it works is you're looking out the window and you have lots of sensory data. And what you're trying to do is to figure out what's the probability that this is a tree given my sensory data. Okay, so that's called the posterior. That's what we're trying to figure out. And it turns out that you use Bayes' theorem for that. And Bayes' theorem, roughly speaking, is to calculate the probability that that's a tree given my sensory data. The way you do it is you have to kind of go backwards. You have to say that's equal to the probability that my sensory, what's the probability that I got this particular sensory data if it was indeed a tree, times the prior probability that there are trees in general, which is reasonably good. That whole thing is divided by a normalizing term, which is what's in general the likelihood that the probability that I get this kind of sensory data. Now, that Bayesian inference turns out to be what's called computationally explosive. So we can't actually calculate it, because to calculate it, you would have to figure out every single hypothesis of where the data is coming from, including, it's a tree, it's an alien spacecraft, it's a snake, everything, and you can't do that. So both in AI and in biology, in evolution, we have to do something called approximate Bayesian inference. And here was the clever hack that was figured out by evolution, and that is exactly what we're doing in machine learning and AI. The hack is, okay, so let me guess at what's going on. Let me guess at what's going on. And you start off guessing as a baby, and the guesses aren't that great. But as you go on, your guesses get better and better. And what you do is you sort of have this neural network, with, coming in from the edges of your brain, where the optic nerve, the visual processing, early visual processing is happening, for example. And you feed forward and say, oh, looks like it's a tree. Okay. This is the basic idea. But in fact, what's really going on is that you've got this idea that it could be a tree, but now the brain says, okay, let's actually imagine that it is a tree. Now the brain fills in the entire picture and guesses exactly what's going on using its prior probabilities, using its best estimates. And then, to make sure that we're not just making it up, what we then do is compare the little bit of sensory data that I got, this ridiculously small amount of the visual field, the few isocards, and compare that sensory data with the output of your simulation of this guess model, right? And you compare your simulation with this few pieces of sensory data, and then what you do is you adjust your simulation, your internal mental model of what's going on. You adjust the parameters, the dials and knobs and switches of that simulation to minimize the prediction error, to minimize the difference between the output of your generative model, that's the simulation, the generative model, and your sensory data. And that's called the prediction error. And as you minimize this, what you end up with is a generative model, an internal simulation, if you like, a hallucination, but it's a hallucination which is a special hallucination, it's a hallucination which is trying to minimize the prediction error with the actual sensory data. In other words, it's a controlled hallucination. And then we get this very important hypothesis, which I call the neurophenomenological hypothesis. Big word, but very important. I'm going to spell it out. Neurophenomenological, basically being that our conscious experience is, in fact, our internal model, or some part of our internal model. Some parts we may not be conscious of, but we are experiencing our internal model. In fact, we are not experiencing the world as it is in itself. That's a philosophical conundrum. We've never actually seen the world as in itself. We are living in our own internal simulation, like a video game, if you think about it, right? And in this internal simulation, we have to represent ourselves as well. So this representation is in fact an avatar within my own internal simulation, within my own internal generative model. And the idea of me is all, and my narrative self and my social self and my bodily feelings, these are all combined to make sense of an internal model. It's very important to have an internal, what's called a phenomenal self-model. It means a kind of internal conscious self-model. So it's very important to have that, because from an evolutionary perspective, if there's a tiger running towards me there, I need to know where I am and that the tiger's over there, and then I can jump up that tree over there. So it's a good data structure, okay, within my generative model to make sure I have a model of the agent itself. And funnily enough, even the idea that we are acting is a part of this agent model. There are other parts of this generative model, which is that, in fact, as another data structure, a philosopher called Immanuel Kant a couple of hundred years ago actually figured out that we also have to have a concept of space and time and causality to organize our sensory data. So we're bringing all of this to our internal generative model. So we are simulating this world with data structures, or they're called hyperpriors, these top-level beliefs using space, time, causality, an internal phenomenal generative model. Now, so that's a very strange situation, and there's a couple of things to note there. The first thing is that we've got a kind of a weird error or an illusion going on, which is that, in fact, this whole experience, this whole conscious model is happening within us. But we think we are this avatar inside the model. So we've taken ourselves to be this little mini me inside of our awareness. That's the first thing that is kind of strange. And the second thing that's kind of strange is that we believe it's all real. This is the real me. That's the real tree. This is the real bottle, right? It's really a bottle. It's not a kind of a representation of a bottle, but it's real. And the philosophical word that we use for real is that we have reified this object. We believe it's the real object. Now, what happens when we start to meditate? We come to see, first of all, that I'm not my thoughts, because we can come to sort of observe our thoughts arising and body sensations arising and emotions arising. And if we're observing them arise, they're not us. And we also come to notice that those are kind of, as we really tune into them, we can come to notice that those are made of fine vibratory sensations. We can start to deconstruct them. We can start to see that these body sensations and these thoughts are fleeting and impermanent. Not only are they not us, but they're fleeting and impermanent and shimmering and diaphanous and almost like fog or have a dreamlike quality. There's a technical Buddhist word called emptiness. Very good word, actually. Some people don't like it. I actually like it. I think that it's a wonderful word. And we come to see that all the phenomena are empty. They're impermanent. They're diaphanous. They're almost translucent and transparent. What we come to see in meditation is that, in fact, what we take to be real is not really real. This is, in neuroscience and philosophical terms, we tend to call that we have de-reified the object, so they no longer are real. And of course, seeing these objects as empty or de-reified is very important, but the most shockingly important part of the meditation process is to see ourselves, all the various components of ourselves, of the phenomenal self-model, as empty. That they are de-reified. They're also not real. They're just constructions. Doesn't mean they're not there. Doesn't mean that they disappear, or that thoughts disappear, or that body sensations or emotions disappear. It's just that they become empty. And the whole notion of being identified with them starts breaking down. And at that stage, something pretty amazing can happen, which is that we can come to see that all of this experience, all this arising, these thoughts, these body sensations, this sound, this visual field, are all arising within a space of awareness or a space of perception, and that it's all constructed, and that who we take ourselves to be is kind of empty as well. And then we can wake up like becoming lucid within a dream. That's an analogy. We can become lucid within our own generative model.